Today, we are going to talk about one of the most exciting and innovative spacecraft in development, the Dream Chaser Tenacity. This is the first of a new fleet of reusable spaceplanes that will soon fly to the International Space Station and back, delivering cargo and, in the future, crew. But what makes this spaceplane so special? And how does it handle the extreme heat and pressure of re-entering the Earth's atmosphere? In this video, we will dive deep into the design and technology of the Dream Chaser's heat shield, which is a key component of its safety and performance. We will also compare it to the heat shield of the Space Shuttle, which was the inspiration for the Dream Chaser, but also had many problems and limitations. And we will look at the progress and challenges of the Dream Chaser program, which is expected to launch its first mission in early 2024. So buckle up and get ready for a thrilling journey into the world of spaceplanes. The Dream Chaser Tenacity is the first vehicle in the Dream Chaser fleet, which is being developed by Sierra Space, a leading commercial space company. The Dream Chaser is a winged spacecraft that can take off on top of a rocket and land on a runway, like an airplane. It is designed to be reusable for at least 15 missions, which reduces the cost and environmental impact of space travel. The Dream Chaser is also versatile and adaptable, as it can carry different types of payloads, such as scientific experiments, supplies, satellites, and even people. The Dream Chaser can also dock with the International Space Station or other orbital platforms and return cargo and samples to Earth. The Dream Chaser is part of NASA's Commercial Resupply Services 2 CRS-2 contract, which awards private companies to provide cargo transportation to the ISS. The Dream Chaser has been selected for 6 operational resupply flights, starting from 2024 after a successful demonstration flight, which is planned for the first quarter of that year. The Dream Chaser Tenacity is not the first spaceplane to fly to space. In fact, it is heavily influenced by the Space Shuttle, which was the world's first reusable spacecraft and flew 135 missions between 1981 and 2011. The Space Shuttle was a remarkable achievement of engineering and science, but it also had many flaws and drawbacks. One of the most critical and challenging aspects of the Space Shuttle was its heat shield, which consisted of tens of thousands of tiles that covered the entire surface of the vehicle. These tiles were made of silica, a material that can withstand very high temperatures, but is also very fragile and brittle. The tiles had to protect the Space Shuttle from the intense heat and friction that it encountered when it re-entered the atmosphere, which could reach up to 3,000 degrees Fahrenheit. The tiles also had to insulate the vehicle and its crew from the extreme cold of space and prevent any damage from micrometeoroids or orbital debris. The tiles were individually shaped and fitted to the contours of the Space Shuttle and had different colors depending on their location and function. The black tiles were used on the nose and the leading edges of the wings, where the heat was the highest, while the white tiles were used on the rest of the body, where the heat was lower, and also to reflect the sunlight and keep the vehicle cool while in orbit. However, the Space Shuttle's heat shield was also a source of many problems and delays. The tiles were very delicate and prone to cracking, chipping, or falling off during launch, landing, or transport. The tiles also had to be waterproofed before each flight to prevent moisture from seeping into them and causing them to expand or explode when heated. The tiles also had to be inspected, repaired, or replaced after each mission, which was a very time-consuming and costly process. The tiles were also a safety hazard, as any damage or gap in the heat shield could expose the vehicle to the extreme heat of re-entry and cause it to burn up or break apart. This was tragically demonstrated in the 2003 Columbia disaster, when a piece of foam from the external tank struck the left wing of the Space Shuttle during launch and damaged several tiles. This damage allowed hot gases to penetrate the wing during re-entry and caused the vehicle to disintegrate, killing all 7 crew members on board. The Dream Chaser Tenacity aims to avoid the pitfalls of the Space Shuttle and improve on its heat shield technology. The Dream Chaser uses a similar material for its tiles, which is also silica-based, but with some important differences. The Dream Chaser's tiles are larger, stronger, lighter, and cheaper than the Space Shuttle's tiles. The average size of a Dream Chaser tile is 10 by 10 inches, compared to 6 by 6 inches for the Space Shuttle. This means that the Dream Chaser needs fewer tiles to cover its surface, which reduces the complexity and the risk of gaps or misalignment. The Dream Chaser uses about 2,000 tiles, compared to about 24,000 for the Space Shuttle. The Dream Chaser's tiles are also stronger and more resistant to cracking or breaking, thanks to more modern manufacturing techniques and coatings. The Dream Chaser's tiles are also lighter and more efficient, as they meet the requirements for micrometeoroid and orbital debris protection and offer the same thermal performance as the Space Shuttle's tiles, but at a lower cost. The Dream Chaser's tiles also have different colors, depending on their location and function. The white tiles are used on the top and sides of the vehicle, where they reflect the sunlight and keep the vehicle cool in orbit, while the black tiles are used on the bottom and the nose of the vehicle, where they absorb the heat and protect the vehicle during re-entry. The Dream Chaser's heat shield has been tested and validated by Sierra Space and NASA in various facilities and environments. The tests have shown that the Dream Chaser's tiles can withstand the high temperatures and pressures of re-entry, and also the low temperatures and vacuum of space. The tests have also shown that the Dream Chaser's tiles can be easily installed and maintained, and that they can be reused for multiple missions with minimal refurbishment. The Dream Chaser's heat shield is also designed to accommodate the shape and features of the vehicle, such as the thrusters, the windows, the docking port, and the control surfaces. The Dream Chaser's heat shield is also compatible with the Shooting Star module, which is an additional component that attaches to the rear of the vehicle and provides extra cargo capacity and propulsion. The Shooting Star module is disposable and will separate from the Dream Chaser before re-entry and burn up in the atmosphere, while the Dream Chaser will glide to a runway landing and be ready for another flight. The Dream Chaser Tenacity is a revolutionary spacecraft that combines the best features of a rocket and an airplane and offers a safe, reliable, and affordable way to access low Earth orbit. The Dream Chaser Tenacity is also a testament to the vision and innovation of Sierra Space and the collaboration and support of NASA and other partners.